Hello dear children, how are you all? Hope you all are fine and doing well. Dear children, this is the third video on competency based questions. I mean this is a continuation, and when I say third video, don't expect that sir, is there any fourth video? No children, I'll try to cover all questions in this, but please don't mind this video going to be almost 1 or 20 minutes, it might be 1.5 hours also. Because already I told you many times, just we are not going to read a question and answer, we are going to discuss in depth actually. So first two videos we uploaded based on the competency based questions. The links will be given in the description, just go through those videos so that to get a command on the few more questions. And in this session especially, we are going to cover question number from 63, 64 to 95. I mean we are going to complete all competency based questions. So be ready with your pen and a notebook. Let us discuss together, let us solve together. I mean when I say let us solve together means what? Whenever question is shown on the board, try to just do that question and try to comment your answer if you are interested. Okay children, are you ready? Let us start. So let us see the today's first question, that is the question number 64 in a competency based question. Children, in question number 64, it is all about some magic show type is going on the stage where a person is trying to lift a iron rod without touching. So what is the secret behind that? Yes, the secret behind, so if you want to understand that, we must understand, we must know, already we know it actually. So children, there is some arrangement setup that a copper wire is there. So when switch is on, current will pass through it and there will be a magnetic field around it. And as iron is a magnetic substance, it gets attracted. So hence that iron block can be lifted without touching only. And the moment when you can switch off that, yes, that magic, what happens? The magic won't work, which means what? The iron block will fall as usual. Why? Because when current is switched off through the copper wire, it acts like a normal copper wire only. It loses its magnetic properties. Okay, fine. So do we have a such arrangement setup? Can we make in a laboratory? Yes, we can make. It is electromagnetic concept. So there you can take one iron nail. So for this iron nail, yes, copper wire winding is done, where you can attach one battery. Okay, now the moment when current is passed through this circuit, it behaves like an electromagnet. Then it gets the properties of a magnet. Then it can attract. If you can place some small iron nails, these will get attracted. Means as long as the current is passing, then only it behaves like a magnet. The moment when current is switched off, it behaves like a normal iron nail. So it is a purely concept of what? Electromagnet. So what is just they are asking even to name one device which uses this concept. Yes, electric bell. In electric bell we use a U-shaped electromagnet. Done, fine. Now let us see the question number 65. So in this question children, one circuit is given. Now across this AB, see here three switches are there. They are asking either of one switch should be opened so that we should have this much resultant resistance, they are saying. In the first question they are saying that yes, you can switch off either S1 or S2 or S3 so that the resultant resistance should be 4 ohm. So for this let us try. For suppose children, let us say this S3 switch is off, I mean to say. So as S3 switch is not working, so current won't pass through it. Then you have to neglect this. You assume that this resistor is not there. Then if it is not there, only 6 ohm, 2 ohm, 10 ohm are there. These 2 ohm and 10 ohm are in series, right? 2 plus 10 is how much? 10. 2 plus 10 is how much? Is 12. So now the resultant circuit I can make like this. So this is how actually I can make. This is going to be 6 ohm. This is a 12 ohm. Now let us cross check the resistance across A and B. So resistance across A and B, as both are in parallel, 6 into 12 by 6 plus 12 is how much? 18. So 6 1 6 3 3 1 3 4. Yes. So we are getting a 4 ohm. So to have the resultant resistance 4 ohm children, yes, here S3 switch should be opened. Okay, fine. Now they are asking us to off any other switch so that the resultant resistance must be 3 ohm, they are saying. Okay, now let us try with the S1. For suppose S1 switch is open, means it is not working. Then only these three resistors are there. So 2 ohm, 10 ohm, both are in series. 2 plus 10 is 12. And it is in parallel with the 4 ohm resistor. So here Now it is going to be, this is going to be 12 ohm resistance, and this another one is, it is going to be 4 ohm resistor. Now let us calculate. RAB is equal to 12 into 4 by 12 plus 4 is how much? Is 16. 4 1s are 4 4s are 4 1s are 4 3s are. Okay, here the resultant resistance is 3 ohm. Now this third one, so I have seen many students are making it complicated. In a simple way also we can. Now let us close one of these switches so that let us say the total current is total current is. So in that 3/5 of the current should pass through the 4 ohm resistor. 3/5 current. So to have that 3/5 of the current through this 4 ohm resistor, which switch must be opened, they are saying. Which switch must be opened. So here S3 and S1 over. So then S2, right? So first one we tried with the S3. Okay, it is over. Then the second we tried with the S1. Okay. Now S2. Here that is not the correct way also. Look at here. For suppose either of one must be on. For suppose let us say that yes, this is off. Let us assume this is off. Then this 4 ohm resistor must be in with the parallel, right? So this entire circuit is in a parallel. In a parallel we have one condition. What is that here? The condition is R1 I1 is equal to R2 into I2. So what they are saying, through the 4 ohm resistor, let us take a 4 ohm. The current must be 3/5 of total current. That is 3I/5. Then this R2 we don't know. Actually R2 we don't know. Okay. Then I2 is what actually? So rest of the current is how much? 2I/5. 2I/5. Now here I get cancelled. So here 5 get cancelled. So 2 1s are 2 2s are 2 into 3 is how much? 6. So R2 is equal to 6 ohm. Means there must be a one more resistor which should be in a parallel with the 4 ohm resistor. Then only 3/5 of the current will pass through it 4 ohm. So 6 ohm resistor is how much? Where is that 6 ohm resistor? It is here. So this should work. And this should work, S3 should work. So obviously S2 should be opened. Children, this type of questions really it's a time taking. See, again I am telling you here, competency based questions, it's not a critical questions. Those questions will take time. So my advice is that if you feel such a questions, if you find such a questions in a question paper, my advice is that better attempt at the end. At the end means not after exam, my dear. It's not that. Once you complete with the questions what you know very well, just do those questions, then come back to this such a questions. Like when we get a calorimetry numericals, what I suggested, try to attempt the question where calorimetry numerical is involved. Try to attempt at the last because calorimetry numericals will take a time. Okay, fine. Copy that. Now let us see the question number 66. Okay, so this question is based on the electromagnetism. Here a north pole is there and here is south pole is there. So as per the question, yes, here this is representation of current carrying conductor which is like this, it is placed and current is passing into the board. Hence, so as per the right hand thumb rule, as the current is passing into the board, yes, field length must be clockwise. That is what actually given. Okay, now let us take a 2 to 3 like this. Okay, clockwise, fine. Now the question is, question 1, state the direction of the force experienced by the conductor. So in which direction? For suppose here the conductor is like this, whether it will move upward or downward or left or right, that they are asking. So very simple thing is that first we should understand here. Here magnetic, see there is a magnetic field around the current carrying conductor and here one more magnetic field is due to the bar magnet and here north and south. This magnetic field will be in this direction, right? Yes, north to south. North to south. So let us say here point A, just I am telling you, it is a point B, let us say that. If you can see above the current carrying conductor, the magnetic field due to the current carrying conductor and the magnetic field to the bar magnet is in the same direction. So hence, as we know that magnetic field is vector quantity, here magnetic fields gets added up, means strength will be increased. But where if you can see below this current carrying conductor, The magnetic field due to the current carrying conductor and the magnetic field due to the bar of magnet is opposite direction. Hence here magnetic field is nullified. Okay, so here strength is more, here strength is less. I repeat once, here strength is more and here strength is less. We know that the force experienced by the current carrying conductor is proportional to the magnetic field. Hence, here more is the strength means more is the force, here less is the strength means less is the force. So I can say that force at A is greater than the force at B. Hence, the net force will be downward direction. Net force is downward direction. Hence, that current carrying conductor experiences force downward direction. Now, the question 2 is explain the cause of the above said. Yes, that is what actually till now we discussed. So, here above the current carrying conductor, the resultant magnetic field is increased. But whereas below the current carrying conductor, the resultant magnetic field is decreased. So here height, so here above the current carrying more force, below is less force. So the net force will be vertical downward direction. Now name the law used to determine the direction of the force. Yes, I said that is downward direction. But which rule we use here? Yes, Fleming's left hand rule. How? You may get a one down. So yes, forefinger should be in the direction of magnetic field north to south. And this should be in the direction of current, and this will give the direction of force. So if you can see, yes, it is in the direction of current magnetic field. Hence, thumb is showing vertically downward direction. Hence, it experiences force vertically downwards. Got it? Fine. And to do this question number 67, we should have some knowledge here. 3 points are very important. 3 points are involved in this question. First thing is that, yes, this question is based on simple pendulum. So whenever we are measuring the effective length, the effective length must be taken from the center of gravity. Try to understand. Must be taken from the center of gravity. First question. Center of gravity. Okay, fine. And here one more point to be noted is that this is the first point. Second one. Frequency is inversely proportional to the length of the simple pendulum. Okay, this is the second point. Third point, very, very important. Center of gravity is situated or shifted towards a point where more mass is distributed. Though in a question all are identical pendulums, like let us take that they are spheres, identical spheres, but they are not completely filled in some cases. They are not completely empty in all cases. So as they are filled with different materials in different amounts, means mass distribution is different. Obviously, the center of gravity also different. Hence, the length will change. Hence, frequency will change. Now, look at here. Here, 4 pendulums are given. Let me just try to draw. It is W. First, let us try to find what we can say. Just notice the center of gravity. As it is a completely filled, yes, its a geometric center will be the center of gravity. And even hollow one also, yes, both are here on geometric center. Children, don't think that, sir, all are having the same length. You cannot say that their frequencies are same. So, effective length must be calculated from the point of suspension to the center of gravity. So, here it's very clear that the length of the x is equal to the length of the z. Okay, fine. And for this, it is not completely filled. So, approximately this should be here. Okay, center of gravity. But whereas here mass is just distributed below, right? So, center of gravity should be here. So with this, so this should be the length in this case. Try to understand. Till here you should take more. Okay, please try to understand. And here the length should be taken here. Means I think just below this. Just below this. Try to understand. So with this I can say that please the length of the y is very much high. Okay, na? And next is length of the w, next is length of the x equal to length of the z. Now with this concept, as frequency is inversely proportional, now they are asking us to arrange the following pendulums according to their natural frequencies, according to their natural frequency. So which one has more frequency here? Y, W, X, Z. So it's very simple. So inversely proportional right here. So length less means more frequency. So here frequency of X must be equal to frequency of Z and greater than the frequency of W and frequency of y is very less. Why? More is the length. More is the length. More is the length, less the frequency. This is the first one. Second bit. If a pendulum Z is initiated into oscillation, which pendulum among the other will exhibit the highest amplitude of vibration? Z. So Z. So in this concept where if you can see here, if you can disturb the Z pendulum and another pendulum also getting vibrated with a more amplitude, that must be X only. Why? Their lengths are matching. That means as lengths are matching, their natural frequency also matches, because their natural frequency also matches. Fine. Give a reason for your answer. Yes, the concept involved is resonance. So resonance is a concept involved in it, children. So already we know the condition. If the natural frequency of the vibrating body matches with the frequency of external force applied, then both will be vibrating with increasing amplitudes. Such a situation, such a phenomena only we can call it as a resonance. So this is a resonance. See, children, this seems to be very simple pendulum. Of course, it's a simple pendulum is not simple in this case. So they made it complicated. So you should be very clear. So here the effective length concept you should have, how to measure effective length. Then you should have you should be strong at the center of gravity, how it gets this one. And third one, how frequency is related to the length also you should know it. If you are okay with these 3 points, yes, you can do such a questions easily. Okay, fine. So with this, question number 67 is over. Now question number 68. So in this question, if you can see, it's a graph based question. Yes, it is a calorimetry question, ma. Yes, so here heat capacity C dash is taken y axis, mass is taken x axis. So here we got 2 graphs. So for metal A, metal B graph. Okay. Now plot a graph illustrating the relationship between the mass and the specific heat capacity. Here you should understand one important thing. Heat capacity depends on the mass, but specific heat capacity does not depend. Which means what? Though you can increase the mass, specific capacity does not change. So then how can we represent with a graph? In a graph, look at here. So let us take a mass on x-axis, specific capacity C. So you will get a straight line parallel to the mass axis. Why? As you are increasing the mass, so specific capacity should remain constant. Why? Specific capacity does not depend on the mass. Is the point clear? Fine. Now, which material is relatively better conductor? Children, if you want to know which conductor, which material, either material A or material B is the best conductor, you should know which conductor has more specific capacity. You make it a one doubt, sir. How can we calculate? Yes, we can calculate. Let me erase this. Okay, fine. Question 2. Okay, try to understand, children, here. So specific capacity is inversely proportional to delta T. This point to be noted. Okay, na? Fine. And we have this relation. C dash is equal, that is the heat capacity is equal to mass into specific capacity. If you want to calculate a mass, what is specific capacity? So C dash by M, which means what here? C dash, that is the heat capacity is taken y axis, mass is taken x axis, which means what? We have to find the slope. We have to find the slope to calculate the, to know which material has more specific capacity. It's very clear that the slope of A is more than the slope of B. So as TA is greater than, theta A is greater than theta B, I can say that specific capacity of material A is greater than the specific capacity of material B. Now, the material with a more specific capacity shows less rise in temperature, less fall in temperature. Whereas, the material with a low specific capacity will show more rise in temperature, more fall in temperature. So, best conductor means should show more rise in temperature, right? To show more rise in temperature, should have a less specific capacity. Hence, material B, yes, is going to act like a best conductor. Not going to act like it is a best conductor. Okay, fine. Now, question number 69. Can I erase this? Hope copied. Yeah, let us do it. Children, see the questions from 60 to 90 almost. So, here simple questions only, but it takes a time to understand. For me also it takes time to explain. So, as I told you that just I am not going to just dictate the answer, whatever is given in the key. So, we don't want that. We want a correct explanation. Yes, it may take a time. It may be 1 hour or 1 hour 20 minutes today's class, but still we are going to discuss each and every question in a depth so that you should understand completely and you should not have any kind of confusions. Okay, fine. Question number 69. Question number 69. Yes. So one experimental setup is given. You can see on the screen. What will be the observation of the compression balance when we close the switch? Very clear, children. So here, let me make one rough diagram, whatever is given. Okay, it is like this. Two arrangement setups are there like this, and here is current carrying conductor is there. Okay. When you close the switch, yes, current will pass through it. Okay, na? Current will pass through it. Then whenever current passes through it, what happens, ma? What happens? It produces magnetic field around it. Hence, below that, so if you can see that one place between the two poles of a magnet, okay, the entire setup is placed in a compression balance which shows a weight of 0.4 kg. Yes, so in this case, very clear that you can find that the weighing machine shows, it's more reading. The reading of the weighing machine increases. Why? Because the force will act downward direction. It is compressed downwards. So just imagine situation where you are standing on a weighing, weighing machine, and if you try to just apply some force vertically downward direction, it shows what we can say more reading, right? So that is the concept here. Of course, here purely it is again concept of electromagnet only, because the current carrying conductor, whenever it is placed in between two magnets, it experiences force. It experiences force. So it is a north and a south. Second one, how will this observation change when we increase the current in the circuit? Yes, when you increase the current in the circuit, more magnetic field is produced around this current carrying conductor. Hence, it experiences more force. It experiences more force. Hence, more reading will be increased. Okay, fine. Now, name the rule used to come to this conclusion. Fleming's left hand rule. Fleming's left hand rule. So here, current is flowing like this, right? Yes. So you can see here. So current is flowing like this, north. So means see, it is not like this. Try to understand. Current like this. So it is placed like this. Okay. So this is a current direction, field direction. So thumb is showing vertical downward. So force acting vertically downward directionally. That is how it exerts force on the spring balance. Hence, reading is shown. As current increases, it experiences more force, more is a reading. Okay, fine. Now question number 70. Fine, children. First of all, in the question, yes, you can see on the screen, clarity is missing. Whatever the diagram which is given is a very simple one only, but by seeing that, even I also thought so much. First I didn't understand what is the diagram and all these things. Okay, na? So I have done I also went through Google and what is this diagram and all these things. Then I got idea actually. So this question is based on in a smart way of opening the door and closing the door. Of course, we got a system where just you can, while you are entering into the room, just you can push the door and automatically will be closed. Okay, but that can be achieved with the help of tumbler also, like any weight which is suspended. But how it will work? Children, very simple. First of all, just think that a door is completely closed. Let us say now door is completely closed. Let us say from inside we are thinking, inside. Okay, now closed means that whatever the thread will be like this, and here one weight is suspended like this. This is a arrangement setup. Door completely closed here. Door completely closed. Now either the person is coming from outside, or you are trying to open within the from inside the room or outside. Let us say that okay, you are outside. Okay, now you are trying to push the door to enter into the room. So as when you push the door, what happens? Yes, door is opened, and don't you think that yes, so the thread system will come like this. Means here, this is what actually, see, here this is a weight. It acts vertically downward direction. This weight is nothing but the force is acting. Okay, na? And here, don't you think that in a simple way, I am not going in depth, in simple way I will make it clear. And here is a perpendicular distance. Perpendicular distance. So in this case, whatever the weight which is acting is a pivot point, let us say that. So it is going along with that. So hence the turning effect will be 0 where the door is closed. Now the moment when you apply the force from outside, then the door is opened. Means here you have to concentrate on this thread here. This distance increases. This distance increases. Try to understand. And whenever force and the perpendicular distance combination will be there, and there will be a turning effect produced. Okay, so the moment you open the door, then the turning, the torque will come into the picture. Whenever torque will come into the picture, there will be some rotation. There is some rotation. Hence, just you open the door, then as a torque is produced, so to encounter the force which you applied, it has to come back. It has to come back to its original position. More you open, with more speed it will come. Less you open, with less speed it will come. Why? More you are opening means more the perpendicular distance, hence more the turning effect. Less you open, less the perpendicular distance, less the turning effect is produced. Okay, fine. So here which principle, which concept we are using? Principle of moments. Is the point clear? So don't think too much and don't worry, such kind of diagram won't be there, won't be given that exam. If it is given also, full clarity will be there. Full clarity will be there. Picture clarity untundi. Okay, you don't get confused about it. Such kind of blur type and less bright, with a less brightness pictures won't be given. Fine. Okay. Now question number 71. So question number 71. So it is given, power is given. Power of a lens is plus 5D. Plus 5D. And the object is placed at 50 centimeters. Object is placed at 50 centimeters minus. Okay. Object distance is. Now state the nature of the image formed. State the nature of the image formed. And second one, what is a different distance towards or away from the lens the object should move so that the image is not seen. Not seen. So first with this let us calculate the focal length. Focal length let's calculate. So focal length is equal to 100 by power. So this is 100 by power is 5. It is a 20 centimeters. So which means what here? So focus is at 20 centimeters and object is placed at 50 centimeters, which means what here? Object distance is greater than the 2f. 2f. So we know that it is the case 2. Whenever object is placed beyond 2f, image is formed between other end, between f and 2f. That is, it's a inverted image, real image but diminished. So we can say that it is a real, diminished, and by default it is a inverted image only. You make it about out, sir, how are you just concluding the answer here? Base, here I calculate the what we can say, not frequency, focal length 20 centimeters. The object distance is given 50 centimeters. It is like this, try to understand. So here is optic center, it is focus, it is 2f. So this we calculate as a 20 centimeters. So obviously this is 40 centimeters, but the object is placed beyond 2f at a 50 centimeters. Hope you got a clarity now. Clear? Fine. Now second one, what is the different distance towards or away from the lens the object should move so that the image is not seen at all? Yes, object should be moved towards the lens at f. If you place the object at f, image is formed at infinity which can't be seen. Okay, yes. Now question number 72. So this is also, it's a diagram based question. Logic is needed here. Question number 72 here. Yes, children. So especially in this, again 3 questions are there, A, B, C, but let us do from C, B, A. Question C. If we interchange the live wire and neutral wires in a circuit B, will the circuit work? Yes. Whether in a circuit A or B, anything, try to understand. Because we are interchanging live wire and neutral wire, same thing happens. Currently, see, finally circuit must be completed. So it will work. Question B. At present, in which circuit is a bulb glowing? Look at here. First, let us see. So here current is passing like this. No. So circuit is not completed. It is a incomplete. It is an open circuit. Bulb won't glow. But here, like this, yes, circuit is coming. And here both are not in touch. That is how the symbolical representation coming like this. Yes, it is going like this. Yes, yes, yes. Circuit is coming. Yes, it is a glowing. Okay. Okay. So B is glowing right now. And which of the above circuits will be able to switch on and off the bulb using both switches? So switch 1, switch 2. Switch 1, switch 2. So let us try with the first one. For example, if I tap the switch 1, it gets disconnected. It gets connected. Now it is completed. Yes, bulb is glowing. Okay. Now I will switch off this. Yes, disconnected. So by using switch 1, I can on and off. Okay, come to here. I will tap the second switch. It gets disconnected, it gets connected. Yes, the current, it is completed, hence current is flowing, bulb will glow. Now once you tap this, it gets disconnected, it gets connected. So in a case A, either by switch 1, switch 2, either of one can be used to on and off. It can be used. Now let us try here. It's already glowing. Okay. Now let us try to tap the switch 1. It gets disconnected, it gets connected. Now it is off. Now it is off case. So look at here. So is the circuit completed? Ting, 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 ting. No, it is incompleted. So again, if you tap this, it gets connected, hence bulb will be glowing. So in this case, switch 1 is used to on, even for off also. Try with the second switch now. So it is already glowing. Once you tap this, it gets disconnected, it gets connected. So then if you can see here, yes, circuit gets incompleted. So even using 1 and 2 switches, in both cases you can on and off. Okay, fine. And in question number 73, yes, it is based on the current electricity question. As per the question, if you can see, if we increase the current in the above circuit using a rheostat, will the reading of the voltmeter decreases or increases? So reading of the voltmeter, they are talking about terminal voltage. Children, we know that EMF is equal to terminal voltage plus potential drop. This can be written as EMF is equal to terminal voltage plus current and internal resistance. Try to understand. So when means terminal voltage V is equal to EMF minus I into R. Here try to understand. Here the internal resistance increases when current increases. Try to understand. Internal resistance also increases, means this total term is increasing. As this total term increases, obviously this term has to decrease. So hence here what happens, the reading of the voltmeter decreases. Okay, fine. Now question 2. Give a reason for your answer in A. Yes, that is what I said. It decreases. The answer is because as current increases, the internal resistance increases, hence the potential drop increases, hence terminal voltage decreases. Okay. And the C, the present reading of the voltmeter is 2 volt. That's great. And the current in the circuit is okay. When the EMF is 2 volt, the current is given as a 0.8 ampere. That's fine. Calculate the potential drop when the current in the circuit becomes 1 ampere. So of course EMF is given 3 volt. EMF is given 3 volt, and for this the terminal voltage is 2 volt. And calculate the potential drop when the current in the circuit becomes 1 ampere. They are asking us to calculate the potential drop. That's fine. So first here what we have to calculate? We have to calculate the initially what the potential drop actually. So we know that potential, see, from this potential drop is this, right? So V is equal to epsilon minus V. So this is 3 minus it is a 2. So initially the potential drop is 1 volt. Initially potential drop is 1 volt. So now, so with this potential drop, we have to calculate the internal resistance. How? We know that V is equal to IR. V is 1 volt is given, and the I is how much? Yes, 0.8 into R. So R is equal to it is 1 by 0.8. If you can calculate, you will get as a 1.25 ohm. 1.25 ohm. So this is the internal resistance initially. Now they are saying that if the current in the circuit becomes 1 ampere, current circuit, what is the potential drop? So here potential drop is equal to I into R. I is 1 ampere into internal resistance is 1.25. 1.25. Hence the potential drop is 1.25 volt. 1.2 volt. So you should be a bit careful here. It seems to be a bit confused type, but here initially the internal resistance is not given, so that first we calculated. Then by using that internal resistance, we calculate the potential drop, because the potential drop is equal to current into internal resistance. Now the question number 74. Yeah, this question number 74 is based on the center of gravity concept, especially the factors affecting the center of gravity. center of gravity. So question number 74. So what is the question here? Yeah, if the vertical height of the earthen pot, there is a conical shape, height is 12 centimeters. Okay, where does its center of gravity lie? So same diagram I can draw like this for sake of our convenience, no problem at all. Okay, so is it completely filled? Filled with the water completely. Okay, so when it is completely filled, center of gravity is situated h by 4 from its base. So h by 4 means how much? 12 by 4. It is a 3 centimeters from base and 9 centimeters from its vertex. 9 centimeters from its vertex, from base 3 centimeters. Don't get confused. Question B. Pavel poured out all the water from the pot. How will its center of gravity shift towards the open end or towards its apex? Now it is completely empty. Empty means what? Hollow. For a hollow one, center of gravity is situated at a h by 3 height, that is 12 by 3. So 4 centimeters. 4 centimeters from the base, and here is 8 centimeters from the vertex. Means now center of gravity is shifted towards the vertex. Try to understand. It is shifted upwards by 1 centimeter. By 1 centimeter. See, Powell wanted to grow a plant in the given pot, so he filled it completely again with some soil. What will be the new position of its center of gravity? Again it is completely filled either with water or soil or mercury, what it may be. Again the center of gravity means completely filled case. Yes, 3 centimeters from its base, 9 centimeters from its vertex. That's it. Now question number 75. Yes, it is a work power energy concept. The question, yes, let me draw the diagram. Of course we are showing on the screen, but still, so then only I am able to explain. It's my comfort. Okay, so here is a, yes, block is given. Here is a force of 50 Newton is applied on a block, and this angle is a 30 degrees. The first question, what is the work done by the force along the inclined plane? So along the inclined plane means force into displacement AC. Force is how much? 50. Displacement AC is given in the diagram 8. So this is 400 joules. This is a work done along the AC. Along the AC. Okay. And the second question, find the gain in potential energy of a block P if it is directly lifted from B to C. So from here to here we are lifting directly. So whatever the work is done is stored in the form of potential energy, that is WBC is equal to, it's a mgh. But height is what here? BC. So m is what? Mass. Mass is given how much? 5 kg. G is a 10. Height is BC. So it's the opposite side. It's a right angle triangle, right? So let us take a sine theta is equal to opposite side by hypotenuse. So BC is equal to AC into sine theta. Let us apply the concept here. So 50 into AC is how much? 8, and sine theta, sine 30, 1 by 2. 1 by 2. 2 ones are 2 fours are. So this will be 200 joules. So work done is 200 joules. Now the question C is, we know that the potential energy is gained due to the work done on the body against the gravity. Then in this case, why is the work done on the block and the increases in the potential energy of the block different? So if you can see, in the case AC actually, so how much difference is there work done? Here 400 joules, here 200 joules here. Here the work done and the potential energy increased by only 200 joules. So according to law of conservation of energy, it must be equal to the work done actually. So along the AC, but why here different? Because along the AC, so on that some friction is present. To overcome the friction, some extra work must be done. So some extra energy is used. That's what always, if it is a rough surface, remember that always the work done along the inclination is always greater than that of the work done to lift the body vertical upward direction to the same point. Okay, fine. Now question 76. So this question also based on same concept. Okay. Question number 76. Are you all able to see what I'm trying to explain? Yes, some light. Okay. So here is this is a diagram given. Still let us take. So here 3 parts. Okay. Let us take 3 parts. This is enough part. This is A, B, C. This is D. So each height is h. This is height h, h, h. The total height is 3h. There is a kitchen. So they are asking what is the potential energy at a point A. At a point A, potential energy is equal to mgh. So mass G remains constant. H is how much? Total is h, 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 3h. So the answer is 3 mgh. This is a potential energy at point A. Okay. Now question 2 of the 76 here. Kinetic energy at a point C. At a point C, try to understand. So as the body is coming vertical downward direction, try to understand. Potential energy decreases, kinetic energy increases. So according to law of conservation of mechanical energy, as air resistance is neglected, at any point the sum of the potential energy and kinetic energy must be equal to the 3 mgh, because this is the total energy at a point A. Now they are asking at a point C. So I can say that at a kinetic energy, point C is equal to, so means this must be here, the kinetic energy is losing here. Okay, so sorry, again, what a kinetic energy is increasing A to C, but whereas the potential energy is decreasing, right? So whatever the loss is there in the potential energy should be equal in the increase in the kinetic energy. Increase the kinetic energy. So according to that, we can say that here. So here mgh is lost. At a point C, what is the potential energy? Mgh only. Very simple. Mgh only. As a potential energy mgh means what should be the kinetic energy? 2 mgh. Why? Because the total is 3 mgh. So this should be 2 mgh. Because the sum of this potential and kinetic energy must be equal at any point of its journey, as we are neglecting the air friction. That is what we are taking the ideal case. Okay. Now question number 77. Okay, here some exhibition, everything is given. Here the students, they are making periscopes by using a normal mirror, that is a normal plane mirror, and a periscope. That is situations. Now the question A, in which of the 2 periscopes, mirror or prism, Anushka, not heroine, Anushka saw the image brighter? Obviously the case where we are using the prism only. Why? That is the question 2. Why is one of the images brighter than the other? Because in the case of prism, total internal reflection takes place, whereas on the surface of the mirror, normal reflection will take place. We know that during the reflection on normal plane mirror, some energy is absorbed, whereas during total internal reflection, no energy is absorbed. Full, complete light will get reflected. Hence, complete reflected light will reach our eye, so that image will be more brighter. Like whatever the brightness is there for object, same with the same brightness we will get the image. It happens only with the total internal reflection. That is possible only in the case of prism, not in the case of normal plane mirror. Okay, fine. Now question number 70 is, yes, this I must draw. Yes, so this diagram given. So the question is that what is the angle of incidence at the surface AB? Okay, first if you want to do that, very important children. So this total angle is given. Children, this we know that this is a 90, right? So from 132, this 90 will go, means this should be 42. Try to understand. 42 plus 90 is 132. So this is 92. This is 90. This 42 means this must be 42. Opposite angles. Okay, because to have this total 90, 40 means this should be 48. 48 means this should be 42. Okay. And here, yes, this is normal given. So this should be 42. No doubt. Okay. Now. So this total is 90, right? This total 90 means to have this total 90, already 42 is gone. So this has to be 48. So the angle of incidence is 48 degrees. That's the first question. Okay, fine. Now what is the critical angle for the glass block? Now if you can see, this is a point where light is grazing the surface. So this is the angle of incidence for which angle of refraction is going to be 90 degrees. So hence, the angle of incidence is 48. The critical angle is 42 degrees. Third one, what would happen to the critical angle if the temperature of the glass block is increased? Remember that critical angle is directly proportional to the temperature. As the temperature increases, dear children, critical angle also increases. Critical angle also increases. That is the question number 78. Now the question number 79. Question number 79. So I think previously we have done the same type of question. Calculate the force of friction offered by the surface AB. So first calculate the work done along AB. Work done along AB is how to calculate force into, okay, displacement is 3. So this is 600 joules, okay. Now work done in lifting the body from C to B, let us calculate. This is mgh, we know already, okay. Mass is given how much? 30. G is a 10. I think height also given 1.5. Yes, this is going to be a 450 joules. Now how much work difference is there here? If you can see, yes, the work difference will be minus WCB. So this is going to be how much? 600 minus 450. It is a 150 joules of energy is lost. So its work done is obviously is lost against the energy is lost against what? Against the friction. To overcome the friction, this much amount of work is energy is lost. Means here the question is that to have this much of amount of energy lost, what should be the amount of friction? So work is equal to force of friction into displacement. So it is 150 into is equal to friction into displacement is 3. 3 ones are 350s. So force of friction is 50 newtons. To overcome this much amount of force of friction, 150 joules of amount of energy must be wasted. Waste means wanted we are not doing. To overcome that, it has to happen. Okay, fine. Now the question number 80. This question is based on the first chapter. That is the first chapter. Okay, so let me just draw the diagram. As I told that I will more comfort when I draw only. Okay, yeah, so this is the diagram given. Okay, and this is a point A, here is a point B, and here is a center, and here is a diameter. You can take a diameter like this or like this also, it's not a problem because it is a circle, right? And here is a one force acting here, F1, one more force acting here, F2. I think both forces are same only. 20 Newton is acting here, 20 Newton is acting here. Means both forces produce moment, torque, but they are asking us to find the ratio of the torque. If you want to find the ratio of the torque, first you must calculate the torque produced by two forces. So first let us calculate the torque produced by first force. So F1 into R1. F1 is how much? 20 Newton. But perpendicular distance, try to understand. So this is the axis of line of action of force, right? So this is going to be the perpendicular distance. As per the question, diameter is given 0.2. 0.2. So this will be 4 Newton meter. Now let us calculate the torque produced by second force. So F2 into R2. And this is a question, part of the question where students will do mistake. R2 means here you cannot take a 0.2. You may get doubt. How? Because this is going to act like a pivot point, right? So now this is a line of action of force. So now this we should take as a R2, which is nothing but the radius, not a diameter. Here this is equal to the diameter. Here it is equal to radius only. That is how much? 0.1. So this will be 2 Newton meter. Now you can take the ratio. So tau 1 is to tau 2 is equal to 4 is to 2. That is 2 is to 1. So this is how we can calculate. So you should be very careful. So whenever you are calculating the torque, so-called moment of force, children, so you must be very clear with the perpendicular distance. Once you are okay with the perpendicular distance, then only you will get the correct answer related to the torque. Okay? Yes. Now question number 81. Question number 81. Yes, this question number 81 is based on the electromagnetism. As per the question 81, yes, here two current carrying conductors, okay, as usual it is given. So in both cases the current is flowing vertically downwards. Children, don't forget that whenever current is flowing through the wires, yes, there will be a magnetic field produced around the current carrying conductor. That is the basic concept. Now try to understand here. Yes, there is a magnetic field produced due to the A, there is a magnetic field produced due to B also. And here you can understand one more thing, you can imagine that this wire B is placed in the magnetic field produced by A, and even you also can think like this, wire A is placed in a magnetic field produced by B. So both are in magnetic fields. So obviously B will exert some force on A and A will exert some force on B. So that is the main concept here. Now read the first question. State the direction of the force experienced by wire A. Wire A. First, if you want to understand that, here let us apply the concept of right hand thumb rule here. As a current is flowing like this, yes, thumb should be in the direction of current, yes. Now the field will be like this. Field will try to understand. So around this field will be like this, right? So this field will be like this, force will act like this. So field, so that is, this is a direction of magnetic field. Direction of magnetic field due to the wire B. Due to the wire B. So this we come to know with the help of the what we can say right hand thumb rule. Now to know the direction of force acting on wire A, we must apply the Fleming's left hand rule. So current direction, okay, and field direction should be like this. So now field, wait, let me just try. Oh, here a small mistake, yeah. So this is a, it's not a, parallel magnetic field lines. So it's not like that. So around the current carrying magnetic field lines are circular like this. So they are like a closed loop. So then field won't be there like this, ma. So please try to understand. Field will be like this. It is going like this, coming like this. Please try to understand. So this is field. So here magnetic field will be on A. It is downward direction. Cross symbol is vertically downwards. Means field, magnetic field is inside. Magnetic field is inside. Current is downwards. Then the force acting will be in this direction. So force acting on A is right side. Please try to understand. The magnetic field due to the wire B on the A is into the board. Into the board. The current is downward direction. My thumb is showing the direction of magnetic field. Clear? Okay. Now second question here. Name the law or laws used to come to the conclusion. Two laws we used. One is a right hand thumb rule. Second one is Fleming's left hand rule. Third one, when a compass is placed in between the two wires, it does not remain along the direction of the magnetic field, wire A or wire B, at one of the points. Achha, 3 points are given here. Some point P, some point Q, some point R. Okay, state with the reason at which point you will observe this. So, and here one more point is given. The current flowing in a wire A is greater than the B wire actually. So, wire A produces more magnetic field than that of the B. Now, at which point you are placing the compass so that the compass is not like directed in a particular direction, which means what? They are talking about the neutral point. That must be a neutral point. And remember that neutral point is always shifted or it will lie near the point where magnetic field strength should be less. This wire is having more current, more magnetic field. Here less current, less magnetic field. So obviously it has to be towards the wire where which carries a low current. So the point should be R. The point should be R. Now the question 82. This is based on what? Displacement force. Yes. So the graph is drawn between the displacement and the force. Kind of graph is given. Okay. So I think as usual I need to draw. So it is not a smart board, but we are discussing in a smart way. Okay. Okay. This is good. So it's a 5, 10, 20, 5, 10, 15. Sorry. 0, 5, 10, 15, 20, 25 is given, and here 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is a displacement, but it is in centimeters. Force in a newtons, and here on one clue is given. It is in SI system, it is in CJ system. Conversion should be done. Okay. Now question is that what is the potential energy stored in the bowstring when the force is 25 newtons? So they are asking potential energy. Potential energy is nothing but the work done. Then how can you get the work done? The area under displacement of force graph gives you the work done, which is equal to the potential energy. So area under means you can take any point, either you can take this, see, corresponding force, corresponding displacement should take. If you can take 5, here 1, 20, 2, 15, 3, like that you should take here. So 25 means this one. So yes, last one, sorry, the diagram I did not do properly. Okay, so it has to be like this. So we know that force into displacement. Force is 25. Displacement is, don't take 5, you must convert into meters. So that is a 0.05. So 5 5s are 25. So it is a 125. So if you can, and one more thing, it is not directly F into S, right? So it is the area of the triangle, means into half into base into height. So this base is 25, base is nothing but the force, and the height is on the displacement 5. Okay, so this is 0.125, it is by 1 by 2. So then if you can calculate, this is going to be 0.625 joules. Okay, this is the potential energy stored in the bowstring when the force is 25 newtons. 25, you may get one doubt, sir, why you need to take 20? Because they mentioned 20, right? So that the corresponding displacement is taken. Now part B of the same question. It is there, if the mass of the arrow is, okay, if the mass of the arrow is given 31.25 grams, okay, calculate the maximum velocity attained by the arrow. Children, try to understand here, according to law of conservation of energy, potential energy must be equal to kinetic energy. So potential energy must be equal to the kinetic energy, expecting there is no loss of energy. So potential energy, how much we got? 0.625. Okay, kinetic energy formula is half mv square. So this is half into mass is 31.25 grams it is. You must convert into kg. So by 1000 into v square. So if you can simplify this, how much you get approximately? V is equal to, you get a 6.32 meter per second. Of course, you do the calculation, you get it. That is the velocity attained by the arrow. Third one, calculate the maximum height reached by the arrow. So potential energy, we know that is a mgh. So h is equal to potential energy by mg. Potential energy, how much we got? 0.625, and mass is how much? 31.25, but you must convert into SI unit by 1000 into 10. So if you can just simplify this, you will get as how much? Yes, here I have done already. You can cross check, it is a 2 meters. Are you able to see? Fine, children. So here you should be very careful with the even graph. The question is given is based on the radioactivity. Now here the point C is located here. With the help of this, they are asking us to write the atomic number, mass number of the C. First try to understand. For C, children, if you can see, the atomic number is how much? Yes, it is, see, 91, 92, 93. Is it 93? Yes. So 93 because number of protons. And mass number means number of neutrons plus number of protons, right? Corresponding mass number is how much? 146. So mass number is N plus Z. So this is 146 plus 93. This is going to be how much? So 146 plus 93, 230, is it 93? Wait, let me check here. Sorry, this is C is at a 92 more. Please try to understand. Please excuse me. So this is C. So this is 92 then. 92, this is 92. So this is going to be 238. So 238 is a mass number and 92 is a atomic number. Fine. The question is that in point B, plot on the graph the daughter element after emission of beta radiation by the element C. So if it is emitting a beta radiation, try to understand. So C is 92, 238. So let us say if it emits beta particle, that is -1, 0. So due to the beta particle, atomic number is increased by 1. Let us say this is converted into some E or B anything, then there won't be any change in the mass number. So which means what here, it place has to be changed, means right side one, and there is no change in the mass number. Means it has to be here 93. One more thing here, 238 means number of neutron is decreased by 1, right? Because during the beta decay, one neutron is decreased by 1, but the proton is increased by 1. That's very important. So here 146 should become 145. So yes, so it should be 145. Yes, and its place should be at a 93. It is a 93. Now you can count mass number. Atomic number is 93. Mass number 93 plus 145. It is going to be 238 only. Okay, now so this is E. Place should be here. Okay. Now the daughter element, as indicated in the previous answer, if it undergoes alpha decay still, again it is undergoing what we can say alpha decay. So during alpha decay, what happens? Atomic number is decreased by 2. Mass number is decreased by 4. So this is the new element E 93 238. If it emits alpha particle, helium 24, let us say one new one B is formed. So atomic number must be 91, mass number might be 234. So atomic number 91 means what? It has to shift here. Yes, so this should be this for indication. This is fine. Mass number should be how much here? 234. So mass number is 234. Atomic number is 91. Now number of neutrons we have to find. Why? Because on y-axis number of neutrons are shown here. Okay, this is 3. Okay, here is 10s. 10 minus 9 is 1. It is 4. So 143. So 143 means here and here. So this should be 143. So this should be the location of B. Is the point clear? So here let me check with the key also. Bit doubtful. 83, right? 83. So the atomic number is 91, correct only. Mass number is 143. Yes, correct. Is correct. That's it. Okay, na? So this is how we have to solve. Now next question 84. Can I erase this? Okay. Yes. Question number 84. Question number 84. So here again it's based on the relation between the length and frequency. Children, first let us write the length of these wires. So length of the D is greater than the length of the A, greater than length of the C, greater length of the B. So common frequencies. Frequency B is less than the frequency of C, is less than the frequency of A, is less than the frequency of D. Okay, now let us read the question. Experiment, why only one ball vibrates vigorously? Out of 4, we don't know which ball. Unless and until you know the frequency of the box. So why only one ball vibrates vigorously means that ball must be in a resonance with that whatever the wooden base. Means the frequency of the wooden base must match with that one of these 4. We don't know what is that exactly. The second question. If FA, FB, FC are the natural frequencies, then arrange them in the increasing order of their frequencies. So increasing order of this frequency means what here? This should be more, because length less means more. So greater symbol should come. AD. Okay, that's it. Question number 84 is over. Question number 85. Question number 85. So here is the question, same. It is here is the concept where a total internal reflection concept is involved. So as per the question, here it is given 48 and this is 90. That's it, not more than that. Critical angle is 42. Okay. Here light ray is incidenting like this. Okay. Now children, try to understand. This will go undeviated. Why? Because it is a normal incidence. It will go undeviated till here. Okay. Now here you should make a normal. So this is 48, it is a 90. This has to be 42. Then this must be angle of incidence is 48. Children, the critical angle is given. So according to that, angle of incidence is greater than critical angle. Hence, a total internal reflection will take place. So with the same angle, it will get reflected. Okay. So this should be 48. Then it should be 42. It is 42. It is 90. Then this must be 48. Then what is the angle of incidence here? Because it is a normal, right? Yes. So this has to be 42, children. 42. And the angle of incidence here at this surface is equal to critical angle. Then light ray grazes the surface. Like this it will go. So if you can see, actually it has to come like this. It has to go, if there is no prism, light would have traveled in a straight line path like this. Straight line path. Now even they are asking us to find the deviation of PQ. PQ is this. PQ. So this is a deviation produced, right? How to calculate the deviation produced here? So wait. So let us try to extend this. Emergent ray is going like this. So this is the deviation produced. This is the angle of deviation. So then for that we should know this one. This is how much? This you should know, right? How much it is? So this is 90. This is 42. So it must be 48. Yes, 48. This total is 180. From 180, if you can subtract 48, so you will get is how much you are getting. It's a 132 degrees is a angle of deviation. Okay. Yes. Now question number 86. It is based on again resistance and all this same concept is involved. Question number 86. Yeah. So as per the question, I think you can see on the screen, resistance of mercury in the tube. They are asking us to write in terms of, so provide the answer in terms of A, L, D. A is what here? A is area of cross section. Okay, let me just write area of cross section. Okay. And L is, okay, L is L only. And EMF is capital E. Okay. And D is what here? Mercury of resistivity. Resistivity is D. Okay, first they are asking us to write resistance. Resistance means we know that rho into L by A. Now let us write this D L by A. D L by A. Over. That's it. Second one, the ammeter reading. Ammeter reading is what? Ammeter reading is V is equal to EMF is equal to I into R. From this I is equal to EMF by R. So EMF is E, R is how much? D L by A. So this is A into E by D into L. That's it. That is the answer. Question number 3. So what is the voltmeter reading? So voltmeter will show reading E. Actually it is given already. Okay. Now which of the measurements are altered when the tube is entirely filled with mercury? So when you are filling with the mercury, means the resistance increases. Obviously resistance will alter, resistance will change, even ammeter reading also will change. Resistance and ammeter reading will change. Okay. Yes. Now question number 87. Yeah. So question number 87 is a quite interesting. So all these questions are interesting only. You may get out. So each and every question you are saying interesting. Actually it's interesting questions, right? So I should say like that. Question number 87. So here if you can see, situation A, student 1, student 2. There you can see the question on the screen also. Demonstrate using mathematical calculation that path followed by student 1 is devoid of frequency. So devoid of frequency means there is no friction. Means you must show that potential energy must be equal to kinetic energy. So for A1 let us calculate. First potential energy. Potential energy is equal to mgh. Mass is how much more? 100 grams. So 0.1. G is a 10. Height both are 5 only. So this is 5 joules. Okay. Now let us calculate kinetic energy. Half into mass is how much? 0.1. V square. V is how much? 10 square. 10 square. 10 into 10. So this will be, it will become 5. Will it become 5? So it is a 0, 1, 10. 10 by 2, it is a 5 joules. Yes. So here potential energy equal to kinetic energy, which means what? There is no friction involved. There is no friction involved. If friction is involved, you know, total potential energy won't be equal to total kinetic energy. There must be some loss in energy against the friction. Now B. Does a situation involving student 2 exhibit a breach of the law of conservation of energy means? No, actually. Why means, let me tell you, in the case B also, we have to calculate potential energy. First let us calculate. So potential energy is same thing, mgh only, that is 5 joules only we will get, same thing. But kinetic energy, half into 0.1 into V square, but V is in the second case 8. 8 into 8. This will be 6.4 by 2. This is 3.2 joules. 3.2 joules. You make it out, sir, where is the rest of the energy? Yes, rest of the energy is used to overcome the friction force. How much it is? 1.8 joules of energy. Means it's a practical case. Here law of conservation of energy is not what we can say, is not violated. Why? If you can see the total potential energy equal to kinetic energy plus energy wasted to overcome the friction. This much energy is wasted. It is a practical situation. It is an ideal situation. Okay, fine. Question number 88. So some students are not understanding this diagram, you know, sir, what is this spikes type, the diagrams are given, how to understand. Let me tell you. So question number 82, some clarity also missing. For a submarine A and B, for case A, if you can see one diagram is given, yes, it is. So here you can find like this one spike where it is given 10 and it is a transmitter one. So here receiver wala, here it is given 40. This is very important for us. It is a time and it is a displacement. Okay. Whereas for a B case, so here clarity is missing in this actually. But I will give you clarity, you don't worry. Okay. So for this transmitter, this time is given. It is not given. Here 20 is given, here 40 is given. So this has to be 30. That is how you should think. Okay. Now for a second case, yes, like this. So this also in between 40 and 60. So it has to be 30. Now look at here. This time difference is how much, ma? Delta TA is how much? 30 seconds. And here the time difference is how much? 20 seconds. Time difference is 20 seconds. Now the question is, name the device used here actually. It is a sonar technique, sound navigation and ranging. Okay. B. Why is ultrasonic sound used in this device? Because of high directivity, can be confined to a narrow beam, and its energy also more, can travel long distances without getting absorbed by the medium. So these are the special directivity, these are the special properties so that ultrasounds or ultrasonic waves are used or preferred in a sonar concept, sonar technique. Now, which submarine is closer to the ship? Then you can understand. In which case you can hear the sound. Here it is taking 30 seconds, 20 seconds only. So it is a closer. B is a closer. B is a closer. It is a transmitter. It is a receiver. It is a 2, let us say 2, what it may be. Now, calculate the distance of the closest submarine. So we know that V is equal to 2D by T. From this, D is equal to Vt by 2. Children, speed is given, that is 1500. The time is 20 is given. So it is a 2. 2 ones are 2 tens are. So distance is equal to how much? It is a 15,000 meters. That's it. So here the data is not given. According to that, we should take 30, 50. Because here 20, 40 in between 30. 40, 60 in between is 50. That's it. Yes. Now question number 89. How many questions are there? Oh my god, 95. Okay, I thought only 90. I thought only 90, but we have to finish. 89. So as per the question, okay, let me draw a diagram now. Let me draw this diagram. Yes, here one switch is placed. Okay, here is the two resistors, and here is one more switch. Sorry. Tungai Kumari. Tanana. Okay, so this circuit diagram is given. This is 20 ohm, this is 60 ohm, this is S2 switch, S1 switch, 5 volt. The question is that the switch S1 is closed and the switch S1 is open. Then calculate the power consumed. Okay, so switch S1 is closed, it seems. Okay, S2 is open. So means what? These two are in parallel. Now we should calculate the resultant resistance. So resultant resistance is equal to 20 into 60 by 20 plus 60. This is 1200 by 80, 0. So 430 is 402. So resistance is 15 volt. Resistance is 15 volt. So, but now they are asking us to calculate the power. To calculate the power, children, we must know the resistance. Then only we are able to do it. Okay, na? So 15 ohm. Now we know this actually. Power is equal to V square by our concept. V is 5 volt, right? So it's a 5 into 5, but it is a 15. So this is 25 by 15. 5 5 is a 5 3 is a. So power is how much it is? 1.67 watt. So this is the power consumed when switch S2 is open. Second part of this, let us see that. Now here S2 is closed, S1 is open. Now the current will pass like this only. That's it. Means this resistance is shut now. So what is the resistance of the circuit now? 20 ohm only. So R is equal to 20 ohm and V is given, it's a 5 volt. So P is equal to this V square by R. This is 5 into 5 by 20. 5 ones are 5 fours are. So 5 by 4 is how much it is? 1.25 watt. So this is a power consumption. So let me check when a switch S2 is closed and S1, sorry, here S1 is open, then it's a 1.25. Okay. Now question number 90, children. Here most of the students are getting confused. Here really it's a, okay, you copy this, we'll discuss. It's a very interesting, of course, don't think like a complicated. Interesting, where we need to work more. It's a challenging question, children. When you can solve these challenging questions only, yes, your talent will grow. It is not like let us do always easy questions. No, talent, but always challenging questions should be. Okay, fine. Now this question is based on pulley cum lever concept. Okay, I think diagram and everything is shown on this one. Question 1 is calculate the minimum effort needed to just lift the beam. So means in a first case, children, try to understand. Just to lift the beam means this beam is going to be like this. Just to lift. Okay. Means this point is going to act like a fulcrum. Then the middle point only load will act. This is where effort is acting. So it is lever now. You forget about the block and tackle diagram. Lever it is. So this is effort arm. Effort arm is how much? 3 meter. Load arm is how much? 1.5. You may get one note, sir. How can you say exactly 1.5? For a regular body, the total weight of the will act as the middle, right? So this distance will be 1.5 meter. Now the question is that calculate the minimum effort needed to just lift the beam here. What is the minimum effort? So apply the principle of moments. So according to the principle of moments, so here effort into effort arm, effort into effort arm. Let us say effort is X is equal to load into load arm. So effort is X, effort arm is how much? This is 3, load arm is 1.5, and the load is how much? Load total weight. So 100 kgf. 100 kgf. 3 1s are 3, 0.5. So x is equal to 50 kgf. Okay. Now this is a 50 kgf we got. Now the challenging is the second part. When the beam is being lifted from the ground, the other end touching the ground. Touching the ground means what? Exactly now it is lifted, children. Exactly it is lifted. Now it is going to be like this. It is touching. This end is touching the ground. This is a situation. But here, what is the x which is acting 50 kgf? Don't you think that it is acting like a load for the block and tackle system? The effort required only is acting like a load for that block and tackle system. Don't forget that. Now the question is that when the beam is being lifted from the ground, with the other end touching the ground, state with the reason whether the effort needed keeps on increasing or decreasing or remains constant. Remains constant. Did they ask here effort actually even? Calculate the minimum effort needed to just lift the beam. See, now this is a load acting. With this we have to calculate the effort. How? We know that mechanical advantage is equal to load by effort. Mechanical advantage, yes, if the 4 pulleys are there, in ideal case velocity ratio is equal to number of pulleys, which is equal to mechanical advantage. So this is 4 is equal to load is 50 by E. Children, here this effort required only is act like a load for that block and tackle, because the block and tackle system has to lift this. Further, it must apply this much effort. Okay, so sorry, not this much effort. To lift this much load, how much amount of effort is 50 by? It is 4. This will be 12.5 kgf. That's it. These are amount of effort required by the block and tackle system. Now, yes, it's remains constant only when the beam is being lifted from the ground. Other end touching. See, it remains constant. Why? The load remains constant, right? So as long as the load remains constant, effort required remains constant only. Simple logic. Okay, fine. Now the question number 91. This question is based on the block and tackle, sorry, not block and tackle, rectangular glass block. Yes, look at here. Here is a rectangular glass block. Okay. Now they are asking us to show. Let us name it as A, B, C, D. My advice is that, children, for suppose here light ray is incidenting like this. My advice is that first only let us try to prolong. Okay. Now this is a place where normal is drawn. So this is the angle of incidence. Okay. Now as the light is moving from air to glass, it has to bend towards the normal. Okay. Now here you make a normal. When it is emerging out, see, logically you can draw this. Make sure that this light, this path should be parallel to this. Of course, it will be like that only. But okay. This is the angle of emergence. These two are the angle of refractions, and this is this perpendicular distance only we can call it as a lateral displacement. So we do the diagram. Okay. Which of the two pairs of angles remains same during the experiment? Angle of incidence must be equal to angle of emergence. Okay. If the same experiment is performed first with a red, then with a blue light. Don't forget that here wavelength of red color is greater than the wavelength of the blue light. Okay. But lateral displacement is inversely proportional to lambda. Hence, lateral displacement for blue color is more than the lateral displacement of red color. Now let us see the question. I didn't read the question only. Which color will suffer greater lateral displacement? Obviously blue color. Why? Because its wavelength is less than that of the wavelength of the red color. Okay na? Yes. Now question 92. I think these we can solve easily except one more question. Okay. 92. So the question is an element, okay, P, it is Z, it is A. Okay, emits one alpha particle. Okay, is emitting one alpha particle, it seems. Alpha particle is He24. So atomic number is decreased by 2. So obviously here element should change, and the A minus 4. Okay. Now, then two beta particles consecutively to form an element Q. Acha, it's not this one. Let us say some X it is. X. Now this X also emitting two beta particles. Children, remember that if two beta particles they are saying, but whether it is a one beta particle, two beta particle, n number of beta particles, there won't be any change in the mass number. Mass number is same. But if one beta particle is emitted, means atomic number is increased by 1, plus 1 for this. 2 means plus 2. So it is Z minus 2 plus 2 is going to be Z. It is a Q only. Okay. Now the second question, what are P and Q are called? P and Q. If you can see P and Q, atomic number is different, but same, sorry, mass number is different, same atomic number. Then they are called isotopes, because same atomic number, different mass number are called isotopes. That's it. Question 93. This I know to explain in the graph on the board. You can see. What does the portion AB represent? AB represents what? Melting. That's it. B. Why is the portion AB parallel to the time axis? Because during the melting, okay na? So though you are supplying the heat, temperature remains constant. Temperature won't change during a melting, during change of state. C. Why is the slope OA steeper than slope BC? First, children, OA is related to the melting, okay, and here BC is related to the boiling. So remember that here melting means you talk about the ice, specific latent heat. Water means specific heat capacity. So specific latent heat is less than that of the specific heat capacity of the water. That is the reason. That's it. Question number 94. So last two questions. Hey, when I say last two questions, I think some of you are happy. Thank God, finally we are coming to the conclusion of these competency based questions. Okay. So question number 94. So here is, let me make this diagram. Okay. Here is one line. It's not my wish, it's already it is given. Accordingly, I am drawing. One more light ray is coming like this. Okay, fine. So it is, okay, it is given. This is a, okay, here also it is given, sorry, 48. See, this light ray will go as usual, no deviation case. And this is 42 degrees. The critical angle is 48. So less than critical angle means normal refraction, away from the normal. Okay. Now here this angle of incidence equal to critical angle. So this light ray grazes the surface. So that here angle of refraction is 90 degrees. Now it is a 48 means obviously, oh, it is given 60, sorry, it is given right, 60 degrees. So angle of incidence is greater than the critical angle. Then light ray will undergo total internal reflection. This is how you should complete the diagram. Okay, yes. Last one. What is the purpose of being stored at a higher altitude? Why water must be stored in a higher altitude? Yes, so as to gain the potential energy, to store the potential energy. B. When the water is allowed to fall in a turbine, what change of energy takes place? Water potential energy. How many questions are there? I think over it is. So potential energy of water gets converted into kinetic energy, and sometimes some part gets converted into even heat energy also. Friction is present, right? Okay. C. Why is this turbine connected to the armature of a generator? So as to utilize the energy, so as to utilize the electrical energy produced, so that only turbine will be rotating, so that other things we can. Last one. Which basic law of physics is followed by the whole mechanism? Law of conservation of energy. So children, with this successfully, I forgot to wear the watch today, okay. Successfully completed all competency based questions. Children, I told you many times, once again I am telling you, don't worry much about the competency based question. Focus on the content. Yes, you go ahead your preparation. You are doing the best. Children, already you did the best. Now you are doing the best. You will be doing the best. That's it. Just think in a positive way only. Don't get tensed. Don't think too much about anything. You are doing yes, you see, as we are doing well, definitely we do the best in exams also. So be with that attitude and go ahead with your preparation, and we do the best in exams. Okay children, thank you so much. All the very best.